All right, so let's go ahead and get started. I'm sure we'll have some more people join in as we go, but let's make sure we have plenty of time for our chat with Steve. So it is my pleasure that we have Steve Isakowitz with us today. He's the CEO of the Aerospace Corporation, has a long history of working in the space sector, both in government and commercial and just overall space and I guess not academic, but everything else. Looking at advancing space for the public good. Currently, as I said, president and CEO of the Aerospace Corporation, which if people don't know, that's one of the federally funded research and development companies, corporations. Never got the C right. Anyway, so they're not really like an industry, they're more government, sort of. I'll let him explain that. The company or Aerospace Corporation itself has over 4,600 employees, and they support critical space missions sort of across the board. Steve also works on the Space Workforce for Tomorrow initiative, which is looking at building a strong future workforce for the space industry, and that's really how we got connected a couple years ago. So he's got over 30 years of experience in the space field. He's worked at Virgin Galactic, at NASA, U.S. Department of Energy, and the White House Office of Management and Budget. I'm going to leave it at that because I know you've got some slides talking about your background and your career trajectory. So I will hand it over to you.
Thank you, Christy and Amy. And let me see, I'm going to try to pull up my slides here. All right. See if I got the sharing done right. All right. Can you see it okay?
Yes, thank you.
All right, awesome. Again, thanks so much for the opportunity to be here. I wish I would have been there in person. Christy did invite me to go in person. I would have loved to have done it, but world events just have overcome the possibility to hop up there. But it's really a pleasure to do it. What I'd like to do is my whole talk, first half of it, is really just for me to make the case to you, the students out there, why you are in the most enviable position. If I could go back in a time machine, I'd bring myself back to freshman year and say, because it is literally the most exciting and important time for space. And I hope to make the case for that. And then in the second half of our time, I'm really delighted to take whatever questions that you might have about me, my career, and perhaps most excitingly, what's happening in the incredible space industry. So with that, let's hop on in. All right, so when I was young, I got inspired in the space program by many other Americans at that time. I was in elementary school. In fact, I was in second grade when Neil Armstrong stepped on the moon, and most people say that are my age, we got inspired by the Apollo program. I got inspired by the Apollo program. But there was a movie at the time that came out a year before Neil Armstrong stepped on the moon. It was called 2001, A Space Odyssey. And if I could see you, I'd ask how many of you would raise your hand. Some of you maybe haven't heard of it, but I still think it's one of the best space movies out there. Honestly, if you want something that obeys the law of physics, this movie does that, because when you blow things up in space, it doesn't make a noise. But the scene in this movie that really struck me at the time is they had scientists that were going between the Earth and the moon on a commercial space line. It was Pan American, which was a commercial airline company at that time, taking people to and from the moon, as that inset picture shows with the flight attendant there. And I thought to myself, now that's the future I want to live in. I want to live in a future where access to space is open to all of us, that we could, at a moment's notice, each of us have an opportunity to have a journey to the moon. And honestly, that has actually served as a bit of the inspiration of what I've done throughout much of my career. And so with that, let me talk about my career. So I am a graduate, both bachelor's and master's degree from MIT in aerospace engineering. My time during MIT, I was very intrigued with the idea of going back to the movie. I was saying to myself, boy, I would love to start my own company in the space industry. And I remember taking classes at the business school at MIT, and I quickly realized that in order to really start a space company, if you can raise $100 million, you too can have a space company. Well, obviously, no one's going to go out there and raise $100 million. So it was pretty clear to me that, at least at that point, for the space industry, it was really impractical because it was very expensive to get into space. So I thought I'd start by going to Lockheed Martin. I worked on a launch vehicle program called the Titan Launch Vehicle Program. Back then, when I first started my career, the Challenger space accident had occurred, and the White House had decided that commercial satellites should not be flown on the space shuttle. We should not be putting astronauts at risk. And therefore, whatever rockets are flying at the time should go out and provide them as a commercial offering. Lockheed had such a rocket in Titan. I worked on it. We went to commercialize it. I remember we had the best rocket at the time. There was two other rockets that were out there, Atlas and Delta. And I remember doing the study that said, only 2 out of the 3 of us will survive. And I kept wondering which one's going to go away, Atlas or Delta. Well, it turned out it was me at Titan. We did not compete very well on it. And I sort of learned my first lessons of competing in the commercial marketplace. But I also learned that so much of the space industry is being driven by the United States government, and it really was not a truly private enterprise. So from there, I actually had a chance to go work at the White House, and that's what the logo is, as the Executive Office of the President, something that's called the Office of Management and Budget, OMB. Probably most of you haven't heard of OMB, but OMB is the place where decisions are made of how much money to give to the federal agencies to do the things they were going to do, as well as set a lot of the regulatory environment that's out there. And I thought, wow, what better place can I have than going to work in an organization like that, where I had a chance to work directly on NASA programs. I did for a number of years, particularly during the Clinton years. It was a pretty formative years in terms of me really getting insight in the industry. But while I was there, I decided I really wanted to go out and work at an agency that really has firsthand experience. So I went to go work at NASA. No sooner than I got to NASA than we had the Columbia space shuttle accident. And there, faced again, what's the future? What should we do with now that we've lost a second space shuttle? And in that case, I was part of a small team that looked at where NASA was at that time. And so much of it was tied into the space shuttle and the space station. And we had a lot of discussion that said, really, the future of NASA needs to go back to the Apollo program. It needs to go back to unlocking and being a pioneering agency at the frontiers of space, and to go beyond low Earth orbit or the immediate vicinity of Earth. And so the decision, and the hard decision, was made. We needed to retire the space shuttle and reinvest that into the new directions in space exploration. But as excited as I was about that, I also saw that it was still not going in the direction that I wanted to see, sort of more commercial activity, and had the opportunity through future White House at that point, under President Bush and later under President Obama, to go work at the Department of Energy. For me, that was a real left turn, because that's not the space industry, but why I was very interested in. There was billions of dollars at that point being put into clean technologies, renewable energy, tapping into commercial industry, new technologies and solar and wind and batteries. So I decided, I'm going to get that different but very exciting experience, which I did at the Department of Energy. But I knew I wanted to return to space. And finally, my commercial space opportunity opened up, where I had a chance to go work at Virgin Galactic. And for those of you familiar with Virgin Galactic, it's a Richard Branson company that was being inspired by the idea of taking people on suborbital flights up to the edge of space and back. And so I had a chance to join that company as president of it, proved out the basic technology, proved that actually such vehicles could be built. After a number of years of doing that, I had the opportunity to join my current position at the Aerospace Corporation that Christy started to introduce. Aerospace Corporation is a nonprofit. It's called a federally funded R&D center. A lot of these were created in the 1950s and 60s, when Congress realized there are certain technologies that are so important to the future of the nation. We needed to have nonprofits dedicated to having the technical depth to be able to support the nation. So that's why organizations like NASA JPL are created for planetary organizations like Los Alamos National Lab for nuclear weapons, Oak Ridge for hard science, and Aerospace was created primarily for the space domain. I was very lucky at the time also. I became the seventh CEO of the Aerospace Corporation. And like everything we do here at this company, we number our CEOs 001, 002. And yep, I got to be 007. That was pretty cool. So at the Aerospace Corporation, I'm just showing you here a picture of our headquarters. But for those of you that are wise and onto what I'm showing here, this is not the Aerospace headquarters. If you look closely enough at that building, you'll notice that logo looks a heck of a lot like our logo, but that is actually the logo of the Avengers. So many times people confuse the company saying, hey, are you an Avenger? And my answer is always yes. We are Avengers. We are the original Circle A, and I'd like to think that we inspired the Avengers series that came out of us, as we have a lot of superpowers that I can tell you about, and some of them I won't. All right, let's get on with it. So why is it the most exciting time in space ever? I'm going to make it on 4 points. One is unprecedented lowering of the cost of access to space. This was the key that really unlocked what I couldn't get as a student in school, which has completely changed the economics of space. Second, it's being used to solve some of the hardest global challenges that are out there, which for me is a very inspiring reason to be in the space industry. Third, because we are truly working at the edge of the space frontier. And then fourth, it really is a great place for an exciting career. So let me just step through each of these. Let's talk about lowering the cost of access to space. So since 1950s and 60s, the United States' space launch vehicles have primarily been dependent on these two launch vehicles, the Atlas and Delta, the ones that I mentioned earlier knocked me out when I was working on the Titan program. These two rockets were actually born out of the need to build an ICBM in 1955 when President Eisenhower said, we need a missile capability to be able to deter the Soviet Union in terms of nuclear war. And the Atlas and the Delta rockets were born. Well, generations upon generations of changes, that missile became a space launch vehicle, took up the early astronauts into space, have truly been the workhorse for decades. And the rockets that are being shown in this picture bear no resemblance to those earlier ones from the 1950s and 60s. They've come a long way. Generally, they were quite expensive to take things into space. So in the last few years, the United States government decided that they no longer wanted to depend on these rockets and wanted to bring forward a whole new generation of rockets. So as a result, the Delta flies no more, had its last flight about a year ago, and the Atlas is getting ready to fly out its last few launches. So what has replaced it? Well, there's the rocket you probably heard quite a bit about. It's SpaceX. They introduced the Falcon 9 rocket, and the picture there is of the Falcon 9 Heavy. It's truly been the new workhorse for the United States, flying as often as over 100 times in a given year. In the last year or so, another company, United Launch Alliance, introduced the Vulcan rocket, which is a brand new rocket that is actually based upon the insights because ULA operated the Atlas and Delta, took the best of both of them, and created a Vulcan rocket, which just completed its second launch. And then recently, Jeff Bezos and the company that he founded, Blue Origins, flew the New Glenn rocket, which flew its very first launch in the last couple of months. And these three rockets were recently selected by the Space Force as being the new workhorses for the United States government in terms of putting national security and even NASA civil satellites in space. But the whole environment of entrepreneurship and new thinking has also driven other companies to be inspired to raise money of their own and to continue to compete. So there's two new rockets that we're expecting to come online soon. One was founded by a company called Rocket Lab. They fly a smaller rocket, which I'll speak to in a minute, and are in the process of developing a newer rocket, which is sort of Falcon 9 class, called the Neutron, which has its first stage reusable. It's an all composite design and an ultralight upper stage. It's very cool in that its payload fairing remains attached to the first stage, and like an alligator, it opens up, releases the satellite, closes up, and comes back as shown in the picture. The one on the right, although it looks like a real picture, it still hasn't flown yet. It's a company called Space. They have a very novel design, and they have a two-stage vehicle where not only the first stage comes back, but they're going to try to bring back the second stage. And they have a very unique approach on how they want to go about doing that. So both of these rockets we expect to be flying, hopefully in their first launches in the next year or two. What has also been very game-changing and has started to really drive down the economics of launch into space is the whole concept of reusability. You see on the left, SpaceX, I'm sure most of you have seen the videos, amazing shots as the boosters from the rockets can come back, land autonomously, be refurbished, and literally within a few weeks be ready to fly again. They have flown a particular booster as many as, I think they're up to 27 launches, which is pretty incredible. Then the one on the right is from their newest rocket, Starship, which I'll speak to in a second. It's a massive rocket, and this picture does no justice on its awesome size. But what's interesting about that is they bring back, of course, their first stage through this so-called chopsticks, where literally the launch pad grabs it as this thing is landing. It's something that I think most people thought would be difficult, if not impossible, and has proven to be very feasible. And I'm sure you've seen it on video. If you haven't, you need to. It's incredibly exciting. And then there are small launch vehicles that carry smaller satellites, one by Rocket Lab, which a company I mentioned earlier. They have a rocket called Electron that actually is a pretty unique design, in that it actually uses electric pumps as opposed to hydraulic to really keep its costs down. And then another company, Firefly, which has its own rocket called the Alpha. These are interesting rockets because what they try to do is go for smaller satellites. Also, because they are smaller and more nimble, they can sometimes be called up much faster than the bigger rockets. So you could do much quicker turnaround in terms of getting them ready for a launch. And then, of course, there's the mother of all rockets. We have now the world's biggest rockets. NASA has developed their own moon rocket called the SLS, or Space Launch System. It has flown a launch as shown here. It's getting ready probably to fly a couple more. It's an all expendable design. The question that's being asked of SLS at this time is, even though it has the capacity to get us to the moon, it's still an expensive launch vehicle. And NASA at this time is assessing whether or not they will continue to use the SLS or whether they'll go to a new generation of heavy launch vehicles. One of them they're looking at, of course, is the Starship, which I mentioned a moment ago. You can't tell from the picture how big this thing is, but the Saturn V had previously been the biggest rocket ever flown, and that was the one that took us to the moon. It was 365 feet tall. This Starship is over 400 feet tall. Having personally stood next to this rocket, it's like standing next to a skyscraper. It's almost like literally launching the Washington Monument. It's an incredible sight. It's powered by 33 engines, as shown in the picture there. The plumbing and that, you can imagine, is pretty complicated and sophisticated. And like that earlier vehicle that I talked about, they're trying the very audacious plan to try to bring that upper stage, the Starship itself, be able to land on the ground and be caught just like the first stage. Elon's vision, of course, is that a rocket like this, like Falcon 9, could be flown over 100 times a year, because you're throwing nothing away, would not only bring the cost down by 90%, which is what current rockets have done versus the old ones when I was in college, but maybe could bring it down another order of magnitude. If we can achieve this, it really will be game-changing in terms of what we can fly into space and the size of the things we can fly into space. So rockets have truly changed the game. It's changed the whole economics of getting access to space, and have opened up this new frontier where no longer you need to be a student to raise 100 million. You could literally, for $1 million, fly on a launch vehicle, test the satellite, and get your next round of funding. So let me talk about the challenges that we're going after. One is space is doing a lot in terms of actually critical for our economy. GPS is frankly one of my favorite examples, in part because here at the Aerospace Corporation, I consider us to be the co-inventors of GPS. It was driven by the notion then that could we use satellites to be able to position yourself from anywhere on the planet Earth? We proved that out, and today we have over a couple dozen GPS satellites that fly in a constellation. There's sort of the half joke where someone says, "Why do I need GPS? I can just look at my iPhone to tell me where I am." Well, I don't think people fully appreciate how critical the GPS is in everything we do, from our iPhones, our autonomous vehicles, our financial systems, even our agricultural systems depend on GPS for farming. It is a critical element of what we do. And because of the cost of launch has changed dramatically, we are now into this era of, instead of launching 1 or 2 satellites in a rocket, why don't we launch 3, 5, 10? In fact, we've recently launched over 100 satellites on one launch. That picture on the right is one of a Falcon 9 deploying the Starlink constellation of satellites, of which today there are over 6,000 satellites just in that one constellation. Amazon is getting ready to launch its new constellation called Kuiper to compete with Starlink, and they too would be launching thousands of satellites. There's the European company OneWeb that is planning to launch over 1,000, and it has 600 in space today. And the Chinese have also talked about putting 2 mega constellations up, as much as 5,000 to 10,000 satellites. So it's unbelievably unprecedented time in terms of having these massive constellations of new satellites that, again, maybe a satellite might cost you 1 million or less in the launch itself, maybe at tens of millions. So it can be really cheap to get into space. The other global challenge that space has been critical to is the role it plays in our national defense. I think I would argue one of the reasons why we are truly a superpower in the world is because we have these satellites that allow us to fight from anywhere in the world, to both observe, get insight, understand threats, and if necessarily, go to war with it. Some good examples are the picture on the top left shows that just before the Russians invaded Ukraine and were denying that they had any intent to invade, it was pretty clear through commercial satellites, in this case it came from Maxar, you could see Russian tanks building up across the border. Bottom left shows, for example, the Chinese as they're deploying a whole new generation of missile silos, on the mainland China that we're able to detect through a satellite that's probably not much bigger than maybe the monitor that you're viewing this from space. And then more recently, when we watched Iran launch hundreds of missiles against Israel, again, satellite technology played a critical role in sort of understanding what the Iranians were going to do. And then finally, when they started to conduct their attack, these satellites play a very critical role in being able to shoot these things down. Now, space in the past has always been, from a military standpoint, has always been about what's happening here on planet Earth and what the satellites do to support it. In the last 10 years or so, that has changed from just actually fighting battles on planet Earth to potentially having to fight battles from space. And it uses the term space warfighting. So as I like to say, Star Wars is no longer just a movie. It's actually the world that we live in. A couple examples that show why this is really important is the Russians recently had launched a satellite as a demonstration that would allow them potentially in the future to detonate a nuclear bomb from space. If that were to happen, that would be horrific in terms of the radiation environment that would create around Earth orbit. That would disable many satellites. It would make it impossible for people to live on the space station and be able to do things from space. That picture on the left, actually in the 1960s, when we were testing nuclear weapons above ground and below ground, we actually did conduct a nuclear weapons test from space called Starfish Prime. In those days, there were very few satellites in space, so it really did not bring harm to the satellites. But today, as I mentioned earlier, with thousands of satellites being up there that are critical to our economy and critical to national security, this is a very destabilizing event by the Russians. The Chinese have demonstrated in the last 15 years ability to fire a missile and destroy a satellite from space. This kinetic is not the only way you can destroy satellites. They have underway plans to be able to use potentially lasers from the ground, things from space, satellites that literally are fighting other satellites in space. electronic jamming, cyber attack. And this picture that's shown here, what's particularly concerning about these so-called kinetic attacks to space is, unlike the ground, when you blow up something in the atmosphere, it just falls from gravity and atmospheric drag to the ground. That's obviously not true in space. When you blow up something in space, particularly if the altitude's high enough, it'll just stay in space. The Chinese did a test in 2008 that created thousands of pieces, dramatically increased the amount of orbital debris in space. And it's debris that is largely still there today, causing very dangerous areas in Earth's orbit. So the United States has been trying to convince other nations to avoid trying to use this kind of method of warfare that could literally destroy our ability to operate from space. Space is important too, from what not only it can do in space, but again, helping us here on Earth. As you know, we had the terrible fires in California, just north of me here. Satellites have the ability from space to detect early on heat sources. And in fact, the state of California has undertaken through a private effort to put up satellites. And there are companies that are pursuing this goal, trying to use satellite and infrared detectors to be able to see the sparks of fires early on. You can catch it earlier on, you can distinguish it. Top right shows a dramatic picture of Antarctica and the climate changes that we're seeing and the warmth that it brings from the climate change. Bottom right, of course, is hurricanes, which has really rewritten our ability to save communities across borders and be able to identify these natural hazards. I already mentioned the risk of orbital debris and explosions in space, but we also get old satellites. And what here is a time-lapse view over various decades. In yellow there, if you could see it on your screen, it shows what are the remnants of orbital debris that we have in space today. It's re-looping again, but if you look closely, as you can see close to Earth, there are literally thousands of pieces of debris that are floating around Earth. And then as you go further out, you could sort of see these lighter clouds of debris that's out there. Now, you might be saying to yourself, well, space is a pretty big place out there. So really, is it a risk that something is going to hit you? As a matter of fact, it is. We're at a place now where if you put things in space, it doesn't take much. Something the size of a marble will destroy your satellite and easily kill an astronaut. And so we spend a lot of time trying to monitor these things. We try to convince people that they need to make sure that when their satellites at the end of their life, particularly for those in low Earth orbit, that they deorbit. And it really does point out the need to have a global regulatory environment where people have a sense of responsibility to not leave up debris and certainly not proliferate that debris. We even have issues today when we launch rockets into space. Actually, we sometimes have to wait a day or two or three until some of the orbital debris that's overhead does not get in the way and potentially interfere with a satellite launch. So it's a real problem, manageable today, but if we don't pay attention to it, it could be unsustainable in the future. And there is a theoretical limit by which if you put so much debris in space, orbits will become completely unusable for many decades, if not centuries. All right, let me wrap up by talking about opening up the space frontier. So first of all, I love the idea that I had a chance to work at Virgin. I worked on that vehicle on the left there called Spaceship Two, taking people to the edge of space. So you too could literally buy a ticket to fly on a Virgin Galactic space plane. You could also fly on a Blue Origin's New Shepard design, and Katy Perry and others recently flew on it. And then the one picture on the right, it's a picture, but SpaceX will also offer you the ability to not just fly to the edge of space, but actually go into orbit. Jared Isaacman, who will hopefully be the new NASA administrator shortly, actually undertook and paid NASA to do what was shown in the picture there, where he had the capsule open up and be able to venture by sticking out a little bit and doing a spacewalk. Recently, in the weekend before, there was also some private astronauts that paid to fly in a polar orbit, which has never been flown before by astronauts, and a very unique orbit. Doing an orbital launch, I will tell you, cost you a whole lot more than the suborbital, but it could be a way of the future. And in fact, NASA is working on the future that could involve commercial space stations where not only research is being done, but by anybody who is willing to pay could have the opportunity to go in Earth orbit. We have a lot of excitement with regards to the moon. As you probably know, in the last month or so, a private company from Texas with funding from NASA actually landed on the moon. The company was Firefly and the vehicle was Blue Ghost. That's a picture there of the vehicle as it had landed. It was actually looking at its own shadow with Earth in the background. A pretty impressive achievement. NASA is hoping to tap into some of these investor-backed companies to be able to do more of the exploration. NASA has also signed a contract with SpaceX to use their Starship to be the human landing system to land on the moon. As you can see there, if you look closely enough at the base of the rocket, you can see astronauts on the surface. They're so small that it just gives you a sense of what is the massive scale if one were to land a Starship. Blue Origin is also later this year going to be landing their own lunar lander system that hopefully in the next few years will also be a secondary way to land on the surface of the moon. Then there's an area that I always think is pretty cool, and I hope it's going to happen in my lifetime, and I think it'll happen in yours, and that is, I think there's a reasonable chance that we will be able to detect life beyond Earth in the coming decades. The more we learn about our solar system and the stars, the more that seems possible. Mars is probably the most exciting place, shown on the picture there on the left. Mars has always been the place that with its thin atmosphere and climate that's reasonable, it has the heat source, it has some of the chemistry. We do believe it had abundance of water earlier in its history. Maybe we'll find fossilized remains, and maybe if we're lucky, there's something below the surface. There are other also objects in our solar system that give promise to the rise of life that we could find. People probably pick their own places they find interesting. I happen to think the moon Europa in the middle picture there is the one that's exciting, because below its icy crust surface shown in the picture there is the belief to be the amount of water that might even be more than on the surface of Earth, that is being heated by a core volcanic activity. And so between the availability of water and carbon elements and sources of energy, wouldn't shock me if that's a place, as well as some of the other moons around Saturn and Jupiter. And then there's this newest field of what's called exoplanets, which is finding planets around other stars with Webb telescope and the Hubble Space Telescope, being able to detect a pixel of planets around other stars, but being able to better understand the chemical makeup of those exoplanets just by examining what they see in that pixel. Last week, I thought there was some pretty exciting news based upon some work done by the Webb telescope, that there is a exoplanet called K2-18b that actually shows the kind of basic chemistry that at least there's one strong argument that says it would only come from some form of microbial life that's giving off these kinds of emissions. Now, we don't know for certain. There could be other explanations, but this is the kind of stuff that NASA, through its current efforts on their telescopes and future designs of telescopes, could probably better indicate whether or not there is life beyond our solar system. And then there's just cool stuff in space. Asteroids. We have a sample that came back from Bennu, the middle one there, and the Kuiper belt. This is like a belt beyond Pluto that has all these weird objects that are the early remnants of our solar system, as that bizarre one that's shown in the middle picture. And then through advances in ground-based telescopes and so on, actually for the first time, we can actually observe black holes, is shown in those pictures there. So that brings you to the conclusion. It's an exciting time because I believe we have some really cool technologies out there that are changing the game: artificial intelligence, swarms of small satellites, robotic and autonomous operations, and new forms of propulsion, be that electric or even in the future, nuclear. There are many companies at this time that are hiring. I think space is one of the industry that is poised for growth, both because of what's happening commercially and what's happening in the government, as well as international interest. I argue one of the best ways to get your foot in the door, if you haven't done this already, is internships, internships, or internships. It's a great chance to actually experience directly from these companies, learn what you like about it, and then see where do you want to go from there. I've also personally enjoyed the fact that I still find that space inspires kids. It wasn't just me, but K through 12 students are often very excited about the whole notion of what's happening in the space industry. And so whether or not they choose this industry, I do believe it is the kind of aspirational work that brings along others to want to pursue science and engineering. And it's just fun. You know, it's sort of captured in these pictures here. The Mars landing there at JPL, the first launch of the heavy rocket for Falcon at SpaceX, or in my time there at Virgin Galactic when we had successfully demonstrated it. And not to be left out, I even had a chance while I was at Virgin at one seminal moment that my team had surprised me with an ice bath to celebrate one of those crazy and fun moments. By the way, it was darn cold.
So we really appreciate your time and your perspective, and hopefully we can host you here at some point in the near future in person. So definitely let me know if you're going to be in town at any point.
Yeah, thank you, Christy. And by the way, just a shout out to you. I know you have been a leader, not only at your university, but through many universities on the things that you have done. You and I have met because of our desire to bring all students along in this exciting endeavor. Thank you for the opportunity to speak, and enjoyed it.
Wonderful. Thank you.